All right, so here's a little bit more practice in section 4.3, which was your logarithmic functions, just to go over a little bit more. Let me clear that out. All right, so we mentioned before that you take the base of your log and it becomes the base of the exponent and vice versa, and how to switch back and forth. So this box is just a little bit of a review box of how to switch back and forth between the two. So let's just make sure we know how to do that. So then what I have on the rest of these is a couple examples to work through on how to solve for these and convert them back and forth. So what you might want to do is work through these and then check all your answers and whatnot. All right, so over here, if we're trying to solve for x, we want to write each equation in its equivalent exponential form. Okay, so this 5 becomes the base, the 2 is the exponent, and then we have it equaling x. All right, so it becomes 5, and then that squared piece equals x, and now we could know that x is 25 if we needed it. So coming over here, it would be b cubed equals 64, and we could solve for that if we needed to. It's 4. And then this last one would be 3 to the y equals 7. That one would be slightly harder to solve for, but we weren't asked to do it. And then this next set of problems, it says change it to their equivalent log form. Okay, so to do that, it would be log base 12 of x equals 2. And again, try these without me first. It would be log base b of 8 equals 3. So 2 to the third equals 8. And this would be log base e 9 equals y. Okay. And then for this last set, that's that change of all right, so continuing, finding the exact value of possible. Okay, so a lot of that would be, if I need to do a change of base, that's fine. So we already mentioned change of base. So you could do log 16 over log of 2. And if you type that into your calculator, it literally would be log button 16 divided by log button of 2, and you get 4. That's because this is the same as saying 2 to the what power equals 16. 2 to the 4. And then this one is asking 3 to the what power is 9. So x is 2. And then this one is saying 25 to the what power gives you 5. So you have to think a little bit on this one. How will you get from 25 to 5? You square root it. So x is 1/2. And again, if you weren't sure, you could do log of 5 divided by log of 25, and it would give you the 1/2 as well. And then you could kind of continue with these. Something I do want to focus on real quick is this one down here. 7 to the what would give you 1. If you start typing in a couple ideas, 7 to the first power is 7, so that wouldn't work. But anything to the 0 is 1. So that brings me to my chart over here, which is your various properties of logs. So first of all, anything to the 0 power is 1. Therefore, if you have a log where the domain is 1, you're getting out a 0. So log 3 of 1 is 0, because this is saying b to the what gives you 1, and the only way to do that is if that's a 0. Okay, so first property of logs. Second one is this idea of the inverse. So if you take a log base b of that same number, you get out 1. So log 10 of 10 is 1. And the reason for that is b to the first power is b. So they cancel back out. Same idea down here. Okay, if I have a log base b raised to the b, that gives you 1. So therefore the x just equals out x. And this is essentially saying, 2 cubed equals 2 cubed. Right. So log 2/8 equals log squared of 2 cubed. They're the same thing. And then this last one kind of has to do with this other one. These are our inverse properties that we talked about a little before. So just make sure you understand them. If you take 5 and raise it to the log 5, those cancel. So you get 7 equals 7. So just a quick know a few of those properties, and then hopefully you'll be able to solve a couple of these down here. Okay, so with these properties of logs, we should now be able to answer a couple of these questions. This one is basically saying 7 to the what will give me 7. Well, that's this one, so I would get a 1. And then 5 to the what gives me 1. That's this one. X has to be 0. Okay. And going through a few more of these, the log 4 will cancel, so I'll be left with 5, and the 6 log of 6 will cancel, so I'll be left with 9. Okay. And just a little bit more when we're working with solving for logs. If they have the exact same base, like in option 2, you can cancel them out. So I might come back to this in just a few minutes. So that was just a couple practice problems from 4.3.